So this video is about pedigrees. Those of you who are dog owners, this has absolutely nothing to do with dog food. What this has to do with are little charts that you can learn things about someone's genetic history from their family. So their pedigree, and I guess the reason like pedigree is used for dogs, it has to do with their parents and their parents' parents. And so if you go back, you can see if they have like a true bred pedigree of dogs. Well, you can do the same thing for people, just looking at their patterns of inheritance. It's kind of like looking at a fancy genetic family tree. So there's a few reasons why we use pedigrees. The first one, just as I mentioned, is that it shows inheritance. The next thing is that it can show you many generations. Typically, they'll show you 3 or 4 generations. And then the final thing is that we're using this to help us develop patterns. So we're trying to figure out if traits are dominant or recessive based on their patterns of inheritance. So it's a different way of looking at things. Instead of doing Punnett squares, you can look at more complex traits and see how they're passed on. In this video, we'll take a look at 3 different pedigrees. The first one, I'll just kind of explain to you how to read them and the information that's in there. The other 2 we'll use to figure out if a trait is dominant or recessive. So just to start off, we'll begin by looking at this one and figuring out a few things that pedigrees show you. For starters, if you look at the key down here in the bottom, the squares represent males, the circles represent females. The black filled in ones are individuals that are affected, meaning that they have whatever the trait is that we're looking at. So let's just say for this one, it's something like widow's peak. So the affected males, the affected ones that have widow's peak, and remember, it's not infected, it's just affected. So somebody who has the trait we're looking for, basically is what we're talking about. And then the open boxes are individuals that do not have that trait. Just because the box is filled in, it doesn't mean the trait is bad. That's one of the things that I think people really get hung up on this chapter. It's like, oh, recessive traits are bad. Not necessarily. Sometimes they can be, but they are not always. Now, if we just look at what this shows you, I said kind of think of it like a family tree. You can see the Roman numerals over here on the side. This represents the generations. So here's our first generation. So we've got our female, which is affected with whatever we're talking about. So again, let's just pretend it's widow's peak. And then an unaffected male. So if we follow them down, you can see that they have 1, 2, 3, 4, 5 children. The way we know this is they're all directly connected to these individuals. Now, if you look at this carefully, only one of their children ends up having a spouse and having kids of their own. The other 4 do not, according to this pedigree. So that's where this person, this male that comes in, is not connected to our first generation because they're sort of like marrying into the family, if you think of it as a family tree. So then once we get down to the third generation, so these 2 people's children and then their grandchildren down here, now we still have these 2 people. They have 4 kids. We've got 1, 2, 3, and 4, and 2 of them end up having a spouse. So we've got an individual marrying in here and somebody marrying in on the other side. And then what you can do is sort of track them, and you can look at their offspring, and we can start to develop patterns of where these affected traits are showing up. And depending on how the affected traits show up, and we know the history of the parents and the grandparents, we can then start to make some assumptions about whether the trait is a dominant trait or a recessive trait. In the next example, we'll start looking into that, and I'll show you some of the patterns to look for. So the first example we'll look at, it tells you up here at the top that this is a recessive trait. Now, they won't always tell you that. Usually I'll just show you a pedigree, and you'll have to tell me whether it's dominant or recessive. But to start off, I just want to point out a few things that makes this one a little bit different than the previous diagram that we looked at. This one has 2 separate groups in the first generation. So since these 2 are not connected, they're not siblings. We've got 2 separate groups of individuals. We have the white ones, remember, that are unaffected. The dark ones are affected. Your job when you have a problem like this, and yours will sort of look like this. It won't have the top part telling you the answer. Your job when it comes to a problem like this will be to go through and to figure out whether or not the affected trait is dominant or recessive. One thing that'll help you, if you look at this, we have an affected individual and an unaffected one, and all three of their kids are unaffected. Now, think to yourself, could that happen if this was a dominant trait? And the answer is no. Because even if this person's heterozygous and this person is a homozygous recessive, even then the breakdown should be 50-50. Now, granted, this could defy the odds a little bit. There are a chance that you could get 3 individuals that are all recessive. So even though that's not definitive proof, that's certainly something that's going to help us support the idea that this is a recessive trait. But if we look on the other side, we have the same breakdown, and this one comes out a little bit closer anyway. They have 1 affected child and 2 that are unaffected. Please be careful when you're doing problems like this. Make sure you take note that this person is not connected to them. So, like, number 11 is not one of the children of 3 and 4. 11 is just marrying 10, which is one of their children. But I want to look at 10 and 11 for a minute. This is something, again, that supports the fact that this one's recessive, since these 2 are only having other affected children. That supports the idea that it's a recessive trait, because if you look on the other side, we have 2 individuals that are both unaffected, and they're having a mixture of affected and unaffected kids. The only way that you would have 100% unaffected kids coming out of a pattern like this is if they're both recessive. There's a chance, obviously, that these 2 individuals are both heterozygous, and that's why we're ending up with some recessive individuals on this side. So these problems can be a little tricky. You just have to try to put some logic into it, and it helps if you can kind of do the possible Punnett squares in your head. Like if you're thinking, well, what are the ways that you could have 2 unaffected individuals that have an affected kid? Well, the only way to do that is to have them both be heterozygous for the trait. If you think back to that Tay-Sachs problem that we did as a class, that one worked that way. You had 2 unaffected parents having an affected child. Now we'll take a look at another one, a problem that's dominant, and we'll see how to sort of figure that one out. So finishing this one up, this, again, you wouldn't see this top part, right? So I wouldn't show it to you saying, oh, it's dominant. I would just show you the pedigree here, and you'd have to go through and tell me what it is. So now, again, we're looking at those dark, filled-in affected ones. We're trying to figure out if the affected trait is a dominant or recessive trait. So it's always good to start off with ones where you have both parents being affected. And honestly, this will tell us right away whether it's dominant or recessive. Because if you think about it logically, if these parents are recessive, then there is no way they could have an unaffected child. Because when you're recessive, you're homozygous recessive. And all you can pass on to your kids is the recessive allele. So there's no way that you could get a child that's then different from the parents. So when it's dominant, it's much easier to figure out. The recessive ones are a little bit trickier, but there is no possible way to have a recessive parent on both sides and to end up with a dominant child. So that one's kind of open and closed pretty easily. But again, it just takes some logic and some thinking to go through and figure these things out. One thing to be careful with, again, is just looking at how these individuals are connected together. Like these 2 are not siblings, right? They are from different parental groups, but they're just marrying here and having offspring down at the bottom. Pedigrees are very interesting in that we can look at patterns for more complicated genetic traits. There are things that are not so simple where you can't just do Punnett squares for them, that you can figure out to a better degree anyway if you have a pedigree for the families that you're looking at. So these things can be very interesting. Like I mentioned before with the Punnett squares, I think a lot of this chapter is logic. You have to be able to have some logical reasoning skills to be able to think your way through these kinds of problems. We'll practice some of these pedigrees in class. The more of these you do, the easier they become. All right, so I appreciate you watching. Make sure you take the time to answer the questions at the end of the video. Thank you.